Hello, good morning. We have talked about the power of Internet of Things to prevent blackouts and disruption of activities in mission-critical infrastructure. In this video, we will address the electricity system, focusing not only on generation plants, but also on electricity substations, transmission lines, distribution networks, and home connections. This includes some examples in equipment or machinery involved at generation, transmission, and distribution of electricity. A robust application of the Internet of Things is achieved through installation of sensors on various computers that collect information in real time. As mentioned in the previous video, this information is an additional level to the existing supervisory and data control acquisition, or SCADA system, and to the network information system, or NIS. These systems coexist and already collect data from every transmission and distribution networks. In many cases, data collection is incomplete as the functionality of these systems is predefined by vendors and modifications are expensive and risky. To the Internet of Things role, this is a complement because it increases the functionality of those previous mentioned systems. A good analogy is when buying a new car. You have the option of certain level of configuration, for example, rims, seats, color, equipment, etc. But in case you want to make it much more cooler or sportive, the modifications have to be made by an independent workshop. If you want to have more horsepower and torque, a high-performance suspension, competition headers, or any other feature, you will need to turn it professionally. The Internet of Things adds on an additional level. It's like tuning the SCADA or NIS systems to maximize the data extractions from the electrical infrastructure and enable a more precise automation. With the Internet of Things, we can detect unconventional KPIs which are not typically monitored, such as vibration in generators, the composition of the oil in the transformers, the detection of vandalism in transmission lines, identification of non-technical losses in distribution networks, and so forth. If no errors are detected, they can escalate and cause catastrophes like this, or like this, or like this, or like this. Not only affecting the utility, but most importantly, with great effect to the society, such as this, or as this, or as this. All the network problems started with a minuscule event, which was not identified and was left to grow unnoticedly and became uncontrollable. It is thanks to the technology of the Internet of Things that these extraordinary events can be identified in real time as early warning systems. Tools and devices allow us to observe critical equipment performance and therefore optimize operations to reduce costs. It allows us to take immediate preventive actions when critical indicators go out of the norm. The Internet of Things play a key role in mission-critical services, especially when infrastructure operations provides essential services to hundreds of thousands of people, where it is assumed that continuity of the service will be uninterrupted. Implementing an IoT solution can well be the beginning for improving the energy availability without the need for million-dollar investments. This is all for today, and I'll see you on my next video.